If you have ever watched Star Trek, you are probably familiar with Beam Me Up. It is one of the most famous commands that is issued when any character wants to teleport back to the Starship Enterprise from a remote location. Of course, with our current knowledge and technology, we can't simply say "beam me up" to teleport to another place. Instead, there is a lot of proof that we can teleport in different ways. Of course, it looks nothing like what we see on Star Trek. So, if you are wondering, will we ever teleport or travel the universe, then you have come to the right place. We will take you through a quantum journey of understanding how this may work, with a surprise at the end. Welcome to our channel, and don't forget to subscribe to our channel for more videos. Let's begin with the most important question that all of us have on our minds, which is if there is a possibility of human teleportation. As of now, scientists say that teleportation can pass information, but it would not be able to move matter. That is because we would have to be broken apart at a subatomic level and then pieced back together to teleport. Because of this, the transportation of real atoms is incredibly dangerous. For example, we can send information about someone on a subatomic level and rebuild them in the same way in another location. So, you can think of teleportation as working as a fax machine in theory. For example, MRIs can be used to do this. MRIs scan living tissues already, but if we require one for teleportation, it would have to be incredibly powerful to generate images precisely of one atom per pixel. After that, the reconstruction site would work as a 3D printer. Such a 3D printer would include all the important chemical elements that will recreate you on a subatomic level, piece by piece. In theory, if you can measure all the atoms inside your brain, how they interact, and then reconstruct it perfectly, then it would be the same brain with the same feelings and thoughts as you. Of course, this principle is only theorized according to physics. However, many people wonder if the human at the reconstruction site would be you or a clone of you. It gets even more interesting than this. That is because a few scientists in 1993 revealed that technically, perfect teleportation was a possibility. However, if such teleportation was to work, then the original thing being copied would have to go through complete destruction. If scientists want to measure the accurate quantum state of particles, they must disrupt it first. Scientists have to bounce a photon off the particle to see where the particle is. However, doing this changes the momentum of the particle in an unpredictable manner, which means that all the measurements taken before will be lost as the quantum state is disrupted. This is not the only problem with human teleportation. Another problem is trying to gather the data you need to make this possible. It takes a significant amount of data to read someone down to their atoms, and it is even more challenging to comprehend. Let's take a look at this in practical terms. The human body is made up of more than 37 trillion cells. Did you know that the number of cells in our body is more than the number of stars in the sky? It does not even stop there because each cell has trillions of atoms within it. Lawrence Krauss, a physicist, did a calculation that if you stack a hard drive pile that stores the data of an individual human being, then the stack would reach light years in space, and will take longer than roughly 3 billion years, which is longer than the entire universe's life so far, to upload. If we take this into account, it would be faster to walk somewhere else than to teleport. While Cross said this in the 90s, when technological advances were not booming at this rate, even now, it still might not be possible to capture the data of a living organism. So, the question still remains, is human teleportation completely out of reach for us? Well, as the wise men say, you must never say never. That is because scientists have recently uncovered a new way to gather all the information about a particle, even from a great distance. You might be thinking how this is even possible, and they do this by leveraging quantum entanglement. The theory states that two particles behave as if they are connected to one another, even if they are light years apart. The change in the state of one particle will affect the other one, no matter where they are. Remember that quantum entanglement happens on a level that is naked to the invisible eye. That is because as the smallest of particles interact or split, some of them also stay entangled. Some people also put forth the theory that entanglement may also play an important role in chemical processes, such as photosynthesis, or it can also offer an explanation for how birds can easily navigate with the help of magnetic fields. The best part is that this type of quantum teleportation has been done with individual atoms and entangled photons. That is why scientists are optimistic about the possibility that soon we will have the knowledge and tools to transport even bigger molecules. These include water and DNA. The idea behind quantum entanglement is to send unhackable messages that might give rise to the quantum internet. For example, if an individual has an entangled photon that has an encoded message, then only the person with another entangled photon will be able to understand that message. If anyone else tried to understand this message, then it would change, as the photon will guarantee safe and secure communication as stated by physics laws. Of course, if we apply this to humans and try to scan and entangle our atoms for teleportation, then that would be incredibly destructive. After all, you will have to put someone inside suspended animation, freeze them, and then slice finely to make accurate measurements, which will take more than 1,000 years to achieve. Even if scientists figure out a way to keep someone alive during this process, then they will also be faced with the task of reconstructing the individual with the same atomic accuracy on the teleportation side without messing anything up. Of course, this opens up many possibilities of various things going wrong that would completely defeat the purpose of trying to understand how teleportation works. Besides that, no scientist will get approval from the ethical and review board committees to start working on this idea, as it would mean completely dismantling the human body on a subatomic level. Unfortunately, you can't teleport because, as we established, it would be destructive. Right now, scientists can only do quantum teleportation, which helps them in beaming information rather than actual humans. That is because electrons are much simpler compared to the entire human body, which contains more than 1,000 atoms. This is incredible information to teleport right now, which is why there are no expectation in the scientific community right now to teleport humans. Many researchers also estimate that it will require more than 1,000 bits to encode what is inside our brains. Human teleportation is not a cool thing that you can do like in the Star Trek movies, because it involves our bodies and brains. There are many philosophical and ethical challenges, which is why the approval of conducting such experiments and research will never materialize. The last question would also be if the teleported human will be the same person or a new person with similar construction. So, while you can watch all the sci-fi movies and see how cool it looks on TV, that is not the case in real life, because human teleportation is perhaps one of the most difficult things to do. The stuff our bodies are made of is complicated and will not allow us to magically vanish from one place and reach another. Without new discoveries and knowledge, we can't teleport. What we know right now has shown us how complicated human teleportation is. So, for now, we can only focus on exploring the universe and cosmos in different ways. For now, all our teleportation dreams must be on hold. Unfortunately, you will not be saying, "Beam me up" anytime soon, because the process of human teleportation is incredibly complicated. All this information goes to show how teleportation is not at all an easy task. We hope you enjoyed learning about this phenomenon and learned something interesting from the video. If you want to learn more about such cool concepts, be sure to like and subscribe to our channel.